If we square both sides, we know the radical is going to disappear from the left. Radical disappears from the left, we're left with k plus 9. On the right side, since it's the square root of k plus 1 squared, what that means is square root of k plus 1 times square root of k plus 1. FOIL all that out. First terms multiply, roots disappear, you're left with k. Your outside terms and inside terms will match. You'll have two k's, actually two square roots of k. And multiply your last, you've got 1. So we eliminated one radical, we still have another radical left. No big deal. We can isolate this radical expression now to one side of the equation. To do that, I could subtract k over. Now if I subtract k over here, these k's go away, right? I can subtract 1 over. That gives me 8 equal to 2 square root of k. At which point I could divide by 2 or just go ahead and square both sides, right? It won't matter. If I divide by 2, got 4 equals square root of k. Knowing I'm going to square both sides now to eliminate that root, k is going to equal 4 squared, 16. Now what do we still have to do? Okay, still have to check. Got to take that 16, got to plug back in, make sure that everything works out nicely. Does everything work out nicely? Appears on this one, everything will work out nicely, right? We're not going to have the square root of any negative values, and we're going to have a true statement after we plug everything in. Squaring both sides on this one. Well, let's see here. Root disappears, right? You're left with x minus 3. Over here, we've got some binomial expansion again. So, if I follow the shortcut, squaring the first term, right? It's going to be 2. It's going to be minus twice the product of these guys, so twice the product, multiplying the roots, square root of 2x. And squeeze in here plus x, right? Because I'm squaring that last term, root goes away. Okay, just like the previous problem, got a root expression left, got to isolate that. So moving everything else over to the other side, x's are going to go away. Subtract 2 over, got negative 5 equals, it's negative 2 square root of 2x. If we want to, we can divide the negative 2 over. But we talked about in the last one, right? You could just square both sides. Maybe on this one I'll do something different, just square both sides at this point. So over here we get 25. Over here, if I'm squaring the negative 2, I get 4. Squaring the root disappears and you're left with 2x. So we've got 8x over here. Solving for x, divide 8 over. X equals 25/8. The only thing left to do, once again, is plug in 25 over 8, make sure everything's legit. Is it going to be legit? All right. What was nice about the previous two problems was we already had one square root that was by itself on one side. So I would encourage you on a problem of this type to at least get one of the square roots by itself. Maybe this guy. Doesn't matter. I'm just choosing that second root there. So if I isolate the square root of 3x plus 10, that would equal 3 minus the square root of x plus 3. At which point we square both sides. we're left with 3x plus 10 on the left. And on the right, we can write it out to FOIL if you want. You can follow the shortcut, doesn't matter. If I follow the shortcut, I'm squaring the 3, get 9. I'm subtracting twice the product of these guys, so that's going to be 6 square root of x plus 3. Then I'm going to add on this last guy squared, so radical disappears, there's x plus 3. Left with the radical expression. I want to isolate that radical expression, moving everything else over to the other side. So I'm trying to isolate negative 6 square root of x plus 3. If I move over my x to that 3x, that's going to be 2x. Let's see, you've got 9, you got 3, so 12. You're moving over 12 to that 10. Subtracting that 12 away, you got minus 2. All right, if I square both sides now, could divide over the negative 6 also, but if I go ahead and square both sides, well, let's see. A little binomial expansion here. Got 2x squared, that's 4x squared. Whoops, twice the product of 2x and the negative 2 would be negative 8x. Square the negative 2, get plus 4. That's going to equal, got the negative 6 I'm squaring, so 36. The root we're squaring, leaving us with x plus 3 as a quantity. All right, distribute the 36 through. Got 36x plus, that'd be 36 times 3, that should be 108, right? Quadratic forming here, need a little more room. All right, so everything's to one side now. Got a greatest common factor. Take a 4 out. All right, is this factorable? And by the way, is the 4 relevant? No, 4 is no longer relevant. You can divide that out. Remaining quadratic, is it factorable? Yes. So we've got x, we've got 13 and 2, right? Make it a negative 13 and a positive 2 should work. So, got two factors here. Set each of those equal to 0. Solve for x. X would be 13, x would be negative 2. Only thing left to do is plug those back into the original equation and see if each of them work. Taking out 13, 13 didn't work. We start introducing these rational expressions into the equations. Now that first one there, square root of x equals 2 over square root of x minus 3. You're trying to get a radical by itself on, one side of the equation. There's really a couple ways we could go about doing this first one. If you'd like to condense it down to one radical, would it be okay to multiply both sides here by the square root of x minus 3? Would that be allowed? We could do that, right? We can do that with the equations. Whatever I do to one side, as long as I'm doing it to the other side, everything's good to go. So this would cancel out, leaving you with 2 on the right. Multiplying the roots over here, you'd have the square root of, if I distribute that x through that x minus 3, it'd be x squared minus 3x. Now you can square both sides. Squaring both sides, we're left with x squared minus 3x on the left because the root disappears. We're left with 4 on the right. Quadratic forms, so subtract over the 4. Do a little factoring. Set each factor equal to 0 and solve. X would be 4 and negative 1. Now it's just a matter of checking. Both 4 and negative 1 work. Can't take the square root of negative 1, take that out. 4 though works. Alright, last one. On this last one, you want to continue the same theme as what we did with the first one. I want to clear the fractions first. If you got an equation, we could do that, right? Multiply both sides by square root of x minus 7. In fact, it looks like something interesting happens here when you do that. You know, on the right side, these guys are canceling out. Everything's good over there. You're left with 21. On this side, though, you got to distribute that square root through. So when I distribute to the square root of x, I've got the square root still. And if I multiply the x and the x minus 7, it'd be x squared minus 7x. But notice what happens when you take this square root of x minus 7 times that square root of x minus 7. Roots cancel out, right? You're multiplying the same roots, so the root goes away. That means I can now take this radical expression, isolate it to one side, at the square root of x squared minus 7x. That's going to equal, well, let's see, if I add the 7 over, that's 28. Subtract the x over, minus x. And now, square both sides. All right, squaring over here, radical disappears. You got x squared minus 7x equals. All right, binomial expansion on this one. What's 28 squared? 784. All right, minus twice the product, so that's 56x, plus then x squared. Quadratic appears to be forming. However, if you start bringing the x squares together, what happens? Right? You move one to one side or the other, they go away. Meaning I can take this 56, right? I can add that over to that negative 7. I've got 49x then equals 784. Oh, tell me that 49 goes into 784 evenly. Does it work or not? What do we get if you take 784 divided by 49? 16. Oh, that's awesome. All right, so x equals 16. The question still is, does it work when you plug back into the original equation? It appears that it will on this one, right?